Alright, so the goal of this video is to talk about something called polynomial long division. But we want to start off by discussing why it is that we have this polynomial long division. In the last section, we talked about a type of division and divide polynomials like, for example, this one that we have here on the left. We looked at the expression and we said if we can factor both of the expressions and find something that cancels, that we'll be able to do division that way. So for example, in this one, the numerator turns into an x plus 3 and x plus 2 when we factor, right? And the bottom also has an x plus 3 on it, and so we're able to say that this is an expression that will divide, okay? And we do that by canceling out the common factors. So that's something that we've learned already, and we know that that will work, and that our answer for this particular problem, the division of these two polynomials, gives me an x plus 2. That's very similar to, if we go back to what we know about regular numbers, 18 divided by 3 is something that we can factor very nicely. We can do the same thing. We know this is 6, but if you want to see what we did up here showing up with numbers as well, we can say that this is 6 times 3, and we can do the same thing with 3. This is 3 times 1, and we get that same type of thing happening where I have a common 3 that cancels, and there's your 6, right? 6 over 1 is 6, and that's how we get the answers, right? But if I take a look at something like 20 over 3, that doesn't work, right? I can list all of the factors of 20 I want, or all of the factors of 3 I want, and I'm not going to find anything in common that will cancel, right? So the best that we can do with this one is say, how close to 20 can I get? Well, I can get 6 whole units, and then I say, okay, well, if I have 6 whole units, there's going to be a little bit of a remainder, and I can turn this into a mixed number and say, in this case, 6 2/3, right? That's the best that I can do with something that doesn't divide evenly, is to say there's a bunch of the 20 that I can divide evenly. In this case, 6 whole times I can divide the 3 into it, but I am going to have a little bit of a remainder. And that's very similar to this top problem, the polynomial. I'd like to divide these, and I can divide pretty much any two polynomials I want. The issue is that in this case, x squared plus 5x plus 11 doesn't even factor. Right? So the method that we used on the left here, factoring and canceling, doesn't work for something on the right. Right? And so what's probably going to happen with these two problems is they may not divide evenly. Right? The other possibility is maybe it will divide, or I'm sorry, will factor, but once I look at all of the common factors, nothing will match and I can't cancel anything. But that doesn't mean that I can't divide the two numbers, right? It just means that I can't use the factoring and canceling method of doing that. So the problems we're going to look at are problems that don't factor or don't have anything that cancel, but we still want a way to divide them, and that's where long division is going to come in. So what I'm going to do first is I'm going to remind you about how you did long division when you learned about division in the first place. So we're going to look at an old division problem that looks something like this, right? So what we said for polynomial long division, I'm sorry, for number long division, was that if I can take 14 and I'm going to find out how many times I can divide it into 3. In this case, 14 does not divide into 3 at all, so we're going to skip that and say, well, now let's try 14 into 30, right? I'm looking at the first two numbers. Well, 14 goes into 30 2 full times, right? If I tried to go another time, if I tried to go a third time, I would be over the 30, right? And so I can't do that. And then what we did was we said, let's take that number, the number of times I divided 14 into 30, in this case 2 times, and let's multiply that by the 14, right? So we kind of came down, and so that's 2 times 14, that's 28, right? And then this became a subtraction problem, and we said 30 minus 28 is 2, and then we bring down the next term, right? We're going to say that the 6 comes down, and we have 26. And then we're going to do the same thing again. We're going to say, how many times does this 14 go into 26? Well, let's see. 14 goes into 26 only once, right? I can't go in a second time, or I'd be over 26. So I'm going to say just once, okay? And I'm going to multiply that again, okay? And I'm going to say this is now 14, right? 1 times 14. And this looks like it leaves a 12 behind. And so now we're going to say, okay, how many times does 14 go into 12? Well, it doesn't go in at all, and I don't have anything else to move down, so we can start moving into decimals. But what we're going to say, and what you originally did when you learned about long division, was just say this leftover piece is a remainder, right? We have a remainder, okay, of 12, right? Another way of writing that, if I say something is a remainder of 12, is that I have 12 out of the 14 things that I need if I wanted to do another complete division. So here's my final answer for this. If I want to write it as a fraction or a mixed number, I'm going to say we can do 14 into 30, 306, 21 full times, and then I have 12 out of 14 of the next, like that 22nd time that I'd like to divide this. I have 12 out of 14 of them, right? So again, I could do a little reducing, and I could say this is 21 and then do 6 over 7, right? And I can leave this as a mixed number and say that the quotient, the answer to the division problem, is 21 and a fraction that represents the remainder. Okay, so we're going to do that, but we're going to do that with polynomials. We're going to say, you know what, one polynomial goes into another polynomial some number of times, and there will be a remainder left over, right? So that's what we're going to do with this next problem, okay, which is one that divides really nicely, and then we'll look at some that don't work really nicely, right? So if I'm saying 2x plus 4 over 2, I'm asking you to do a division. Okay, so with that division, we're going to do the same thing. Okay, we're going to turn this into a polynomial. We're going to turn this into something that uses long division. So I'm going to do the same thing with this problem that we just did with the last one. I'm going to say, how many times does 2 go into 2x? Well, 2 goes into 2x x times. Okay, I can't do more than x times, right? I can't do a number of times. So I'm going to say in this case, here's why. 2 or x times 2 is 2x. Okay? And now I can do a subtraction. In this case, that's 0, right? And then I'm going to bring down the 4, right? So it's 0, and then I'm going to bring down the 4, right? So now I'm going to say, well, this is really 0 plus 4, right? So I'm going to replace that. I'm going to say instead of 0 plus 4, okay, I'm going to put a 4 there. Okay. How many times does 2 go into 4? Well, 2 goes into 4 2 times, so I'm going to put plus 2. Okay? And if you notice, if we had done this the old-fashioned way, we know how to handle a problem like this, and we know that the answer to 2x plus 4 divided by 2 is the x plus 2. Right? So I'm doing the same type of problem, but I'm using long division to accomplish it and to keep my work very organized. In this case, this problem divided evenly, and it has no remainder, so I don't have to worry about the remainder. Okay? So let's take a look at one that maybe doesn't work as nicely. So this is where the actual polynomial long division is going to come into play. Right? So with these problems, before I go to the next thing, let me just point this out. This is something that is entirely brand new. We have never seen anything like this. So this is something that's going to take some practice to get used to. You might watch me do this the first time, and you might say, wow, I can't do that. That's going to be really tough to do. With practice, you will do it. I kind of say that this is something like, if you remember in Algebra 1, you learned how to do factoring, and the first time you saw that, it was very difficult. As you practiced it and used it, it was something that became a little bit more natural to you. So let's try that with this problem, okay, and see what happens. Okay, so we're going to find the quotient of x plus 1 divided into x squared plus 3x plus 6. Okay, so here's how we handle these types of problems. We're not going to look at the plus 1. We're just going to strictly look at the x, and we're going to say, how many times does x go into x squared? Okay, well, we're going to say, well, I can go in just one time, right? And here's how I know. One of the x's is here. The other one is the one we're going to bring into the problem, okay? And that's going to make the x squared. So we're kind of looking at this x and we're saying, how do I complete this x squared? Well, I complete it by bringing in a brand new x. So what I'm going to do is I'm going to say, let's put an x here, right? I'm lining it up with where the x is in the original problem. So this is an x to the first. I'm putting that right above the other x to the first inside of the long division symbol. And so now what I'm going to do is I'm going to take this x, and I'm going to multiply it by this expression. So I'm going to say x times x is x squared. And again, line up all of your like terms. Okay, x times 1, well, that's 1x. Right? So I'm going to say, I'm even going to write the 1x there. Okay, so again, I lined it up as I went along. So if you notice, this looks very similar to what we just did with numbers. Okay, and so now I'm going to do a subtraction just like we did. If you remember, if we go back to our normal problem, when I multiplied what was up top by the 14 and brought it down, I then did a subtraction. I took whatever was there and I subtracted off whatever I multiplied down. So we're doing that exact same thing. I'm going to say x squared minus x squared. Well, that's 0. That's a cancel. That's what we're trying to get to happen. 3x minus, so this is where it gets tough. 3x, you got to go out here to see the minus sign. 3x minus 1x is 2x. Okay. So now I'm going to do the same thing. I'm going to say, how many times does x go into 2x? Oh, I'm sorry. Before we do that again, let's bring down the next term. So again, when we went back here as our reference problem, after I did the subtraction, I looked at what the next term was and I brought it down. So we're going to do the same thing with ours. We're going to say, okay, I did my subtraction, 3x minus 1x, that's the 2x, and then I'm going to bring down the next term. In this case, that's this plus 6. Okay. So now I'm going to say, how many times does x go into 2x? Well, I don't need to bring in any additional variables, so I'm just going to say I'm going to try to complete this first term by putting a plus 2 right here. Okay, so watch what happens again. My goal is to get at least that first term to cancel, like what we had happen here. So if I do 2 times x, well, that's 2x. There's that cancel that's going to happen. 2 times 1, well, that's 2. And again, this is a subtraction problem. So I'm going to say 2x minus 2x, there's my cancel. 6, and again, be careful. This says 6. I got to go over here to say minus 2. 6 minus 2 is 4. Okay, so we're at that point again where I reach the end of the polynomial. I have nothing else to bring down. So 4 is my remainder, just like we had back in our original problem. We got to the bottom and we had 12, right? 12 was my remainder. And if you notice what I did, I took the numbers that I was able to write, right, for my 21. So let's start with that. I brought over a whole 21. So in my long division problem here, I'm going to bring over this entire x plus 2. My answer is x plus 2. X plus 1 goes into this expression x plus 2 times, but I have a remainder. So let's see how we dealt with the remainder. Okay, in this problem, I had a remainder of 12, right? Here it is. And I put it in a fraction on top, and then the bottom of the fraction was what I was dividing by. We said I had 12 out of the 14. We're going to do the same thing. Here's the 12, there's the 14, set it up right next to the problem. So watch what I do. I'm going to say x plus 2, I have a remainder of 4, and my divisor in the problem was x plus 1. So I'm going to say right next to this, 4 over x plus 1 is the remainder. What we're going to do to attach that to the rest of this polynomial is just add it right on the end. We're basically saying there was a full x plus 2, and I had a remainder of 4 over x plus 1. This is the answer to our problem. We're going to stop right there and leave it just like that.